Hello everyone, I am Sakshi Kesharwal and I'm a maths expert and Ask IITian. So today we'll be starting with a chapter name that is surface area and volume. So surface area and volume, to be for your kind information, we have been studying since I don't know from fifth grade or sixth grade. So definitely I can give you like surety, like right. So from sixth grade we have started what are the things. So like we have just got into the basics, then sixth, then seventh, then eighth, and then ninth. And this chapter still continues for the class 10. So we have this chapter till class 10 so that you understand the concept slowly and steadily, everything, and that is more important, right? So surface area and volume is things which we do in a day-to-day life, like when you want to do the construction or maybe you want to renovate a room, right? So how many numbers of the plyboards that you want to buy, right? How many, like how much paint is required to color, like you paint, right? Like color your room, right? Paint your room, right? So these are the things which is the practical and the real life example of surface area and volume. You might be thinking, yeah, this is just finding the areas and this is a very calculative. Yes, this chapter is a calculative one, but yes, this is very much important for a day-to-day life also. Like if you want to say that you want to paint the room, right? So how much paint that you are going to buy, right? So first you will just see, this is like one of the thing. Now let us suppose you want to buy a side table, right? And you know what is the area near the side table. So how much big side table that you're going to buy. Sides, the table size varies, so you want to buy the very specific size which is being required by you. So you should know the measurements and everything very properly. And most of the shapes which we see are like the generalized shapes. And yes, and the other shapes which you see like the designer shapes, it's like made up of from the like the basic shapes which we have done, right? So today in the first class, this is the first lecture of the surface area and volume is specifically for the revision of class 8, right? Because this is the topic which we have studied in the class 8, right? So this is a part, like first lecture will be a totally dedicated to your class 8 kind of a revision sort of, right? So last class we have studied about the surface area of a cube and cuboid and a cylinder. We have already done the surface area volume of a cube and cuboid. This we have done. So first chapter is like first lecture is dedicated to class 8. So let's get started with it. So let's have a quick revision of what we have done and let's do some little bit of practice. So that will be helpful for you, right? So let's start with it. Yeah, let's talk about the surface area and volume. It consists of a good weightage around like in your syllabus, like CBSE weightage. If you talk about your CBSE weightage, yeah. If you talk about your CBSE weightage, it consists of 8 to 9 marks. It depends, right? From school to school, because this is class 9th grade, so it varies, right? So yes, this chapter consists of a good weightage and the student loses the marks because of the calculation. Sometimes they understand and sometimes they don't, but they lose their marks because of their calculation. So be very specific. This chapter is going to be a little bit calculative. There will be lots of addition, multiplication, subtraction, and division will be there, right? So let's get started with it. So what are the topics that we'll be covering? This is a topic which is from which we have already learned in a class 8th, right? That is the surface area of a cube and cuboid and the surface area of a right circular cylinder. This we have already done it. So I'll give you a very, I think so we can be a little bit fast and jump to the questions very easily. So you can just see the images over here, the building. The building is in the shape of what, beta? The cuboid, right? Like the sofa is like if you're just going to make a cut from here, here from like the properly. So it is like we took two cuboids and join it. We have given the design, but actually the when we have started making it, it was a what? A cuboid, right? So these are the things which we have in our day-to-day life, right? And if we want to like have, you can say that just okay, so it's like this. You have to just start, like you have so many things, like the bed which you have, it's what, a cuboid. The laptop which you have, it's a cuboid. So many things. The books which you read, all the books which you have is in the shape of what? Cuboids, right? So what are the cuboids and what are the stuffs which we have? So let's go a little bit fast. What are the surface area and the cube of cuboid, right? So if you take this, that is the space occupied by the two-dimensional flat surface, it's called an area, right? So this is, can you see the sheet of paper, right? I think so this is like a little bit blurry, but right. So if you see this sheet of paper, the sheet paper is a what? A flat surface. So it is consist of an area, right? Now it is measured in square units, right? Square unit, it can be a meter, square meter, or it can be square centimeter, it can be square, kilometers, anything, right? Depending on the how big the thing is, right? The area occupied by the three-dimensional object by its outer surface, it's called its outer surface area. Now, if you have, if you have, if you have, let us suppose this is a three-dimensional figure around me, or the like the phone which you have around you, right? So this is the phone which you have around you, right? So this is what a three-dimensional surface. So what is the outer surface area? The outer surface area is the part which you touch physically, like which you can physically feel this thing. Yeah, this is the things which you physically feel, right? These are the things which you physically feels are known as what, beta? The outer surface area, right? Right, and it is measured also in the square units, right? Again, in the square units we are finding the area. Now the surface area formula in the geometry refers to the lateral surface area or the total surface area. Lateral surface area means what? Like the boundaries, like this, right? Yeah, the outer, like this these are the lateral surface area, the boundaries, right? Or if you take this box, right? So this these are what? Lateral surface. Total surface area, by the word, how much area it's covering, like how much portion that you can feel. You can feel this part, 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 you can feel this part. See, all these parts are what, beta? So what are the like cuboids? Let's go a little bit fast. So how the cuboids were formed? Cuboids are formed with what? If you take a rectangle, right? This is what a rectangle is, right? So if you take a single sheet of a paper, like I'll just consider that the thickness of the sheet is negligible, right? So the height which we consider for this sheet is like negligible, right? So this has length and the breadth, right? Now what happens if I start taking like many of the sheets with me, right? It's not, yeah, many sheets with me. So you see that the height has been raised, a little bit height is raised, right? So this is happens with the book. When you start winding up the books, what happens? You have only a single sheet of paper, and then when you start like piled up like 100 or like thousands of sheets, a figure form is what? A cuboid. Yes, you can see that this is a book which I have. So this is will be a what? A cuboid, right? So these are the cuboids, and the cuboids are made up of the what, beta? Six rectangular faces, right? So this we have done in the class 8, that how many faces a cuboid have, how many edges, and the face, what does it have. So we have already done in the previous classes, right? So let's go a little bit counting, little bit fast. So it is made up of the six rectangular like faces. So one rectangle, the second one, right? This is the third, this one is fourth, this one is the fifth, and this one is the sixth. So it is like front, back, side, top, bottom, right? So they are the six faces, right? So all the faces are what, beta? Rectangle. So what it is the things, if we say that this one is a rectangle, this one is the length, right? This one is your breadth, and this one is your what? Height, right? So if I want to find that, if I say find the lateral surface area, what do you mean by lateral surface area? Lateral surface area except the top and the bottom, right? The room in which you are sitting is in the shape of what? It's a cuboid. It's a cuboid, right? Maybe some of you are very specific that the room is what? A cube, right? But it is what generally the rooms are what? With a cuboid. Cubes are generally, we don't have rooms with cubes, right? But depends where do you live, right? So you see that it is like one rectangle sheet, like you have a terrace, right? This is it, this surface, and you just compare that the terrace, right? The bar head where there is a fan, right? So it was like, if I say that this one is the length, this one is the breadth, and this one is the height. So its area, this area, the top portion area is equals to how much, beta? LV, right? The bottom area, these two are what, beta? Congruent figures. This and this are what? Congruent figures, right or not? So we say that this area is LV, and this area is also what, beta? LV, right? Now you just see this area. This is what? This is having a breadth, right? This is having a breadth, and this is having the height. See this surface, right? So this is having a breadth, and this one is having height. So you see that this side of my wall and this side of my wall, like I have a wall, I'm sitting in a room. So these sides of the walls are what, beta? So what will be the area over here? It will be what? BH. Yeah. This will be BH, and this will be what? BH. Now let's talk about the front area, right? So it have a length, right? My front wall and my back wall, the wall which is back of me and the front wall, right? So this is what length, and this one is your height, right or not? Length and the height. What is the surface area? The surface area will be what, beta? LH. And over here also, back is also what, beta? LH. So this is like the total surface area which you have filled it out. So this is what the total surface area. Lateral surface area will be what? Top and bottom nahi hai. There won't be no top and there won't be any bottom. There will be only the side faces, right? So what are the things we get? So what are the things we get over here? I think so all the formulas are written. So let's see what we get. We get two times, like we get two times LB, right? Then we get two times of BH, like side. LB is like top and bottom, right? BH is side, and LH is the front and the back, right? So this is two times of LH, right? Can you take the two common? So this is what, two times of LB plus BH plus LH, which is known as what, beta? Total surface area. In short, we write TSA, just for a convenience that TSA is very short. Right now, what is the lateral? CSA or curved surface area? Right now, the cube do not have curved surface area. So we say this have a lateral surface. Lateral means what? The boundaries. Yeah, we don't talk about the terrace and the bottom, right? So this is what the boundaries. So if I say the side one, the sides are what? The two sides are what? BH, right? So CSA will be how much, beta? CSA is equals to what? 2BH, right? And front and the back is what? 2LH, right? So 2 times of LH, right? So you can take that 2H as common, then L plus B. That is a formula. Now, one more thing, if I say that if this is a cuboid, length is equals to 2 centimeter, breadth is equals to 2 centimeter, and height is equals to 3 centimeter. Is this a cuboid or a cube? This is a cuboid. Cuboid, it is not necessary that if two of the lengths are same, then the third length can be different, right? So this is still a cuboid. Please make attention that this is still a cuboid, right? Now, what is a cube? Cube means what? That the length, breadth, and height. Have you seen the Rubik cubes? I'll just take an example because Rubik cubes are being seen by most of the students, right? If you have seen the Rubik cubes, right now I don't have Rubik cubes, otherwise I would have shown to you, right? So if you have a Rubik cube with you, so you will see that like all the length, breadth, and height, like everything is what, same. So if I say that length is equals to breadth is equals to height, and I'm naming this as A, say, right? And you know what are the edges and the vertices? Edges are basically where the two faces meet, right? Where the two faces meet, right? This is the edge, right? So how many edges that a cube have? A cuboid have 12 edges, like 1, then you have 2, then you have 3, you have 4, you have 5, you have 6, you have 7, you have 8, then you have 9, you have 10, you have 11, you have 12. 12 edges, right? So if I say you what is the length of all the edges, right? So first let's go on the cube. So cube means what? All the sides and all the lengths are equal. So similarly, if I say the terrace area will be what? A into A, right? That's again a square, right? The bottom area will be what? Again A into A, that's A square. So 2A square I got. The side will be what? A into A, that's A square. This side will be what? A into A, side square. Front will be what, beta? A into A square. And the back is also what? A into A square. So how many times we have added A into A? That is what? 6 times. So TSA of a cube is what, beta? 6A squared, right? Now, if I talk about CSA, like curved surface area, that's TSA, and CSA, that's that's lateral surface area of a cuboid will be what? 4 walls. So this is equals to what? 4A squared. That's it. Now, I want to ask you one more thing, that if I say, what will be the area of 5 balls? There is like, if I say to find the surface area of a pen holder. Have you seen a pen holder? Right? So pen holder means what? It does not have a top, right or not? It does not have a top on it, right? It does not have a top. So read out the questions very carefully, what it is saying. So if it says that, what is the area? That is a area of 5 balls, right? Area of 5 balls. So area of 5 balls will be what? Total area minus the terrace, or area of 4 walls plus the terrace, like plus the bottom, right or not? You can just go anyway. So this is what? Area of 4 walls, that is 2H plus L plus B plus LB, that's the bottom, right? So this is what the surface area of a cube and cuboid is. Now let's do on the questions. Directly will jump it out. So hopefully you have understood the things. Now it says that find the lateral surface area and the total surface area of the cube of the land, cuboid of the length 80 centimeter, breadth 40 centimeter, and the height this one. So how we write it? So this is L is equals to what, beta? 80 centimeter, breadth is equals to what, beta? 40 centimeter, and height is equals to what, beta? 20 centimeter, right? Now, first we'll find the CSA. See, if you have done find the CSA, then you can just add 2 times of LB and you'll get the same answer, right? So you can just go either of the way, whatever you feel like. So CSA is equals to how much, beta? 2 times of H into L plus B, right? So this is equals to what? 2 into 20. L plus B is equals to 80 plus 40, right? So this is equals to what? 40 into 120, right? So this is equals to what, beta? 4800 centimeters square. That's it. And what will be your TSA? TSA is equals to what? You can just do like this. Like I have already found out the CSA. So it will be what? CSA plus 2 times of LB, right? No 2 LB was not there, like terrace and the bottom were not there. So I'll just add 2 times of LB, or either you can just use a formula and get it. So I already have the calculation done, that is 48, and 2 times of LB means what? 2 into 80 into 40. So you just add it up. So it is what? 4800 plus it is equals to 32, and this is what? 64, right? 64, right? So you just add it up. So 0 0, and this is like 2, and this is 1 1, right? Centimeters square. That's it. That's your answer, right? So are you good to go with this thing, beta? Yes. Yeah. Now I think so. Answers are already written. So lateral surface area and the total surface area, it's already written, right? Now coming to the right circular cylinder. Before, I want to teach you how the right circular cylinders are formed again, because we have already done it. So I want to explain it again. So if you have the sheet of paper, right? This is a sheet of paper, and this one is your length, right? This one is your length. So I will write it for you something, and this one is your breadth, right? So what you did, you just rolled it. Just rolled it. You rolled in such a way that this points have been joined to this point, right? Right? This point have joined toward beta this point, right? Can you see the circle is formed? The circles is formed, right or not? So you just see one thing, because it is very much important that you should know how these constructions are done. Because what happens sometimes, the questions they ask you, and this is very much relatable to how the constructions are done, right? So you have to think a little bit imagination. So if you just see that once you have rolled it out, right? Once you have rolled it out, this thing, so you have seen that the length has become what? The length has become the circumference of the circle, right or not? The length has become the circumference of the circle. So can I write that length is equals to what? 2 pi r. And can I say that breadth is equals to what, beta? Height? Yes or no? I'll just show it to you. Oh my goodness, I look so blurry, right? So can you see this? Yeah. Yeah, just see this, because I think so, because I am using a virtual background. So the lights and this white sheet is like putting an effect, right? So it's like I'm getting very blurry. So just leave, don't see me. I won't show you my face. Right. Just see this part, right? So if you see this part, this is what beta the length, and this is what your length will become what? 2 pi r, and the breadth will become what? Your height. Breadth becomes your height. So what will be the surface area of this? The curved surface. Now this is going to be curved, right or not? When you're going to do this, this substance is going to have a curved surface area, right or not? Right? So this is how this has been made, right? Can you see this? So length becomes your 2 pi r, and this has become, so we know that the area of a rectangle is what? Length into breadth, right? So what is the curved surface area? It is what? 2 pi r into h. See, what you do, this chapter is very much, once you have understood, there's no need to memorize the formula for every little thing, right? So it is what, beta? 2 pi r, right? Length becomes 2 pi r, and the breadth becomes this. So what is the surface area? Surface area, that's curved surface area, becomes what, beta? 2 pi rh. Now, one thing if I want to ask you, can you just give me, hold on, I'm just closing my camera for just 1 minute. I'll get something for you. Wait, hold on. Yes, kids. So have you seen this bottle? Yeah. What is this? This is what? A cylinder, right? So if you see that the cylinder is having a top, the cylinder is having a bottom. So what is the red portion surface area? If I know the radius of it, what is the surface area? How much, like if I say I want to just cover this red, like how many red sheets, how many like big red sheet I required for this bottle to cover it up, right? So what I'll be doing, I'll be finding the surface area, that's curved surface area or not. So curved surface area formula will be what? 2 pi RH, like 2 pi RH, like pi RH, 2 pi RH from here, right? And H is the height, right? Now if I say to find the total surface area will have this, will have what? It will have the bottom, and it will have it will have a top, and it will have what bit of bottom, right or no? So you will see that the curve total surface area includes the curve surface area plus 2 times the what circles, 2 times the what bit of circle. That's it. So this is how we get the formula, right? Yeah. So you just see this over here. That is what is a TSA. Like you have a cylinder. Why we say a right circular cylinder? Right circular, we generally take right circular cylinder. We don't take any like random circular right circular cylinder. Right circular cylinder, beta what? See this if you have this figure. So the radius, like the center of this circle and the center of this circle, when they are joining and with the like this, they are forming a like 90 degrees. These are from a straight line, right? It's not like a curve, like it's like not a bend line, it's like 90 degree with the radius, right? It's always 90 degree with the radius, so it's like this, right? So that's why we use a right circular cylinder. So what is a TSA? If I say, so what will be your CSA? We right now we did L into B, right? So this is what 2 pi R into H. This is how you got the formula. That is 2 pi R H. That is the CSA, right? This is the formula of the derivation. And let's talk about the TSA. TSA is equals to what, beta? CSA plus 2 times the area of the circle, 2 times area of circle, right? So this is equals to what? CSA is equals to what? It's 2 pi RH plus 2 times the area of circle. Area of circle is what? Pi r square. So pi r square, you see that beta 2 pi r is what? Common. So you get 2 pi r h plus r. This is your formula. So if you don't know the formula, it's okay. You can always derive. If you remember this, that's okay. If you don't remember this, it's okay. But the point is that you should remember this much minimum, right? So now let's do the questions on it. Like what are the questions? It says a cylindrical pillar is 50 centimeter in diameter, right? This is a cylindrical pillar, and the height is what? 1.2 meters. So we, as we have been doing since the basics, like from like journey, like from the junior grades, always when you solve the questions, put your like the while the like put all these numbers in the same unit, right? So find the cost of painting the curved surface area of the pillar at the rate of 12 rupees, 12.5 rupees per meter square, right? So this is what now it's asking in the meter per square. So it's better to convert the centimeter into meter. Yes or no? Because the rate price is given into what? Meter per meter square. So this is how, this is one of the practical example. You think that this is all bakwas. No, beta, this is not bakwas. This is very much useful into day-to-day life. You can go and ask anyone who's an architecture, who's a painter, who's a like a carpenter. They are very good at it, and I have seen them, right? So it says that the pillar has a diameter, right? So diameter is how much, beta? Diameter is equals to how much? 50 centimeter, right? So what is your radius? Your radius will be equals to how much? Radius R is equals to what? 25 centimeter, which is equals to what? 0.25 meter, right? Your height will be how much, beta? 3.5 meter. Now it says that find the curved surface area. So CSA is how much, beta? CSA is equals to how much? 2 pi RH, right? So now depending the pi value, you can take pi value anywhere, right? You can just choose any pi value. Nobody asks you. You can take 3.14 or whatever. So this is what? 2 into 3.14. R is equals to what? 0.25 and H is equals to 3.15. So when you will be just multiplying everything, you will see this will become what, beta? 0.5, right? Into 3.5, when you multiply this, and then multiply 3.14, right? If you multiply this, so this is equals to 35 into 5 is equals to 5 and 13, 17. So 1.75 into 3.14. Now you just do the multiplication and get the answer, and I have the answer with you. So the answer is like 5.5, right? Right. So this is like the curved surface area in the meter square, right? This is in the meter square, right? Now it says that the cost of painting, right? So meter square. So what is the cost of painting? We have the answer over here. So it says that 2 pi RH, when you did the multiplication, you get this, right? So what is the cost? Cost will be how much, beta? The cost will be what? CSA into what? 12.50, right? So you just multiply that as 5.5 into 12.5. So you will get the answer 2.50, which is equals to what, beta? Rupees 68.75. That's your answer, right? Now, coming to the next question. The next question says that, yeah, the next question says, okay, it says that find the ratios of the total surface area and the lateral surface area of a cube. It says that of a cube. So what is a cube? That is a TSA of cube is how much, better? TSA of cube is what? 6a square. And lateral surface area is what? CSA is of a cube is how much, better? The CSA of a cube is what? 4a square, right? So the ratio of what, beta? TSA upon CSA is equals to what, beta? 6a square upon 4a square, which is equals to 3 by 2, which is equals to 3:2. That's your answer, right? Now, coming to that, Mary wants to, now let's read out the question. It says that over here. Now, every time read out the question, these are easy only, right? So it says that Mary want to decorate her Christmas tree. She want to place her tree on the what, bit of wooden block, right? Wooden block covered with the colored paper with a picture of Santa on it, right? So what type of the wooden block? If you take the wooden block, if you say the block word, block is generally a what, a cuboid, right? So she must know the exact quantity of the papers that she has to buy for this purpose. If the box has the length breadth, now if it's mentioning, then it's a what, a cuboid, right? So sometimes like you place a Christmas tree in the like a sort of a cylindrical form, right? Or it's basically it's a frustum, not a cylinder, but it's, yes, it's a cylinder, right? Right. Length, breadth, and heights are given respectively. How many square sheets of paper of 40 centimeters she requires? Now, when you start going, when you start purchasing the paper, like the area is this big, and you get a sheets of this small sheets or not? You get the small sheets for your purpose. Yes or no? These are small sheets, like small little sheets you place it on, right or not? So that is what it is talking about, right? So first, if you are going to decorate something, right? So if you're going to decorate the cuboid, so you're not going to decorate the base and the top, yes or no? The base may you're going to keep it on the ground. Ground part you don't decorate, and the top part there will be a tray. So what you will be finding out? You will be finding out what bit a CSA of the cuboid, right? So what you will be finding out? It's given what bit a given में क्या है? What is given? Given. Yeah. Given is what? Length is equals to what? The length, breadth, and height. Length is what? 80 centimeter. Breadth is what? Weight of 40 centimeter. And the height is what? Weight of 20 centimeter, right? So what do you mean by this? So you will be covering only the CSA. So CSA of a cuboid will be how much, beta? CSA of cuboid is equals to how much, beta? 2 times of H into L plus B, right? So it is what? 2 into 20 plus L plus B is what? 80 plus 40, right or not? She wants to decorate, wait a minute. Okay, I think so. It should be, see over here, I think so. It's is that if she wants to place a tree on the wooden block covered with the colored paper with the picture of the Santa, she must know the exact quantity of the paper she has to buy. So it means what? It's not the CSA. She will be covering the whole part, right? It's talking about, please read it out. So it's like this, my bad. It's like she wants to place a tree on a wooden block and covered with the colored papers with the picture of the Santa Claus on it. She's going to cover the entire part, not the TSA. It is basically the CSA, right? So it is basically going to be what? Yeah, it's TSA. So this is equals to how much, beta? It's 2 times of LB plus BH plus LH, right? So it is what? 2 times of LB is what? 80 into 40 plus BH is equals to 40 into 20 and LH is equals to how much, beta? 80 into 20, right? So this is equals to what? 2 into what? 3200, right? Plus 68, sorry, 800 plus 1600. So you just add it up. So 30, 40, and 56. So this is 2 into what, beta? 5600 100 centimeter square. That's the area that she has to cover it. Now she has to require the number of the sheets. The number of the sheets is what, beta? The sheets are what? You will be using the area of the sheets or not. So the area of the sheets will be how much, beta? The area of square sheets will be what? Area of square sheets. Square sheet is equals to what? 40 into 40, right? Which is equals to what, beta? 16 centimeters square. So number of the sheets will be right. Total area minus the area of one sheet or not. Yes or no? Yes or no? So the number of sheets will be how much, beta? The number of sheets is equals to what? PSA of cuboid minus divided by what, beta? Area of what? Square. Yes or no? So this is equals to what? This is 2 into, see, I didn't multiply. See, what you can do, you can just do the calculation like this, into 600. So this and this cancel. This is 4 and this is how much, beta? 114. Now you see this is 2 and this is 2, this is 1 and this is 7. So the number of sheets required is what, beta? 7 sheets, right? Right? Now, coming to the next question, it says that the solid cylinder has a total surface area of this much, and its curved surface area is 1/3 of its total surface area. Find the radius and the height of the cylinder. So it's given what, beta? TSA is equals to what? 462, and it's given CSA is what, beta? 1/3 of TSA, right? Yes or no? Now, can I write this? Now, can I write this TSA? Now, it says that Now it says that 1 by 2 times of CSA is equals to what, beta? 462, right or not? So CSA is equals to how much, beta? 4, 12, and this will be what, 9? Yes or no? You have the CSA, right? And you have TSA, right? So now let's do the formula. What are the formulas you have? The formulas for this is equals to what? Now, first, let's go with this. It says that 2 pi RH is equals to what? 924, right? And it says that give a close observation. It says that TSA is equals to what, beta? CSA plus 2 times of what? Pi r square, right or not? Yes, which is equals to what? 462, right? So if you're going to place this value, oh my goodness, it's 1/3. Hold on. Please hold on, right? Yeah, it says that CSA is 1/3 of TSA. So CSA is how much, beta? 1/3 is equals to what? 462, right? So this is equals to what? 154. CSA is how much, beta? CSA is equals to what? 142, right? Now, this is equals to what, beta? CSA plus 2 pi r square, right or not? Which is equals to what? 462. So can I write this as 154 is equals to what? 2 pi r square, which is equals to what? 462 plus, so 2 pi r square is equals to what? 462 minus of 154. So 2 pi r square is equals to what? 12 minus 4 is what? 8. And 5 minus 5 is 0. And this is like 3, right? So this is equals to what? 2. If you're going to divide this, pi r square is equals to what, beta? 154, right? Now, you take the value as 22 by 7 is equals to pi r square is equals to what? 154. So this is like 1, like 11, like you see this is 11 twos are, and this is like 1 and 4, right? 1 and 4, right? So this is like 11s are, right? So 1 into 4, right? So this is like 2 ones are, and this is what? 7, right? So r square is equals to what, beta? 7 into 7. So r is equals to how much, beta? 7. So this is how you got the 7, right? Now you want to find the h. So h you can find it by using the CSA. So CSA is equals to how much, beta? CSA is equals to like 154, and this is like 2 pi RH is equals to like 154 is equals to 2 into 22 by 7 into 7 into h is equals to like 154. So 7 and 7 cancel, and you just now saw that this is like 2s are, and this is like 1 4s are, 14s are, this is 2s are, right? 7s are, and this is 2, and this is like 3.5. So h is equals to how much, beta? 3.5 centimeter. You got both the answer. right? So please write it down, all these things. Done writing? So hopefully, like, yeah, we have the answers over here. This is the radius and these are the heights. So now let's do, we have one more question over here. It's the question, it says that each edge of the cuboid is increased by 50%. What the percentage increase in the surface area of the cuboid, right? Cube. So it says that let the edge of cube is like A, right? It got increased by 50%. So new edge will be how much beta? The new edge is equals to what? A plus 50% of A, right or not, right? So this is equals to what? A plus 1 by 2, like I'll go like a little bit like this. It's like 50 by 100 into A, right? So this is like 1 and this is like 2. So this is what? A plus 1 by 2 by A, which is equals to what? 3 by 2A, right? So it says that now, if I talk about like old TSA, the old TSA was what beta? 6A square, right? So new TSA will be how much beta? New TSA is equals to what? 6. This is a new edge, right? So 6 into what? 3 by 2A square, right or not, right? A, here it will go A square, that is 3 by 2 A square, right? So you just see this, this is what? 6 into 3 by 2 A into 3 by 2 A, right? So you just see that this one is 3 and this one is cancelled out, right? So you see this is equals to what? 27 A square by 2, right? Yes or no? So this is 3A. Now what it says that percentage increase. So percentage increase is what? Now you see that which one is the greater one. You see that this one is the greater one. The new TSA is like the greater one. So the percentage increase, the increase value will be how much better? The increase is equals to what? 27 by 2A square minus of uh, it was what? 6A square. So this is equals to what beta? 27A square minus of 12A square upon by 2, right? So which is equals to what? 15A square by 2. Now the percentage increase formula is how much beta? The percentage increase formula is what? Increase upon original value, like original into 100, right or not? So increase is how much beta? 15 by 2 A square upon original is what beta? 6A square into what beta? 100, which is equals to what? Can I write this as 15 by 2 into 6 into 100, right or not? So you just see this is like 2 and this is like 3. No, sorry, this is 5. 5, this is 5, 5, 5. And you just cancel out, this is like 4, 25. So 25 into what is it? 5 is what? 125% increase, right? So this is the formula. Now you just see this. Yes, the percent increase of the cube is what beta? 125. You will see that the answer is already written. You can just see that how the presentations and everything are, right? So you can just write it down how we have done it, right? You just see the original cube edge was this A. The old TSA is what? 6. This is the original, right? This is your original TSA, right? So original TSA is what? 6A square and new edge is equals to what? A plus 5. 50% of A. So you got the new edge. So new TSA, the increase is what? You have to do the subtraction. So subtract it and the percentage increase formula is what? Increase upon original into 100, right? So from here we got everything. So I think so you have understood what we have done in today's class. We have learned how we will find the surface area, how we will find the surface area and the TSA of a cube and a cuboid, which was the revision of your class 8 itself. So hopefully I made it very clear and we have done some questions. So please keep on practicing. And if you have any doubt, please ask it on a PDF and ask with your respective teacher in the class. Thank you so much. Stay safe, enjoy, and bye-bye. Okay, we were doing question number 2, right? So what does the question number 2 says? The question number 2 says that Mary wants to decorate a Christmas tree and she wants to decorate the Christmas tree and she wants to place the tree on the wooden block covered with the colored paper with the picture of the Santa Claus on it. She must know the exact quantity of the paper she has to buy for this purpose. If the box has a length and the breadth and the height is odd word 20, 80 centimeter, 20 centimeter, and 40 centimeters, respectively, how many square sheets of the papers of the size 40 centimeters she requires? Now just think like this. Now when you're going to decorate something, you cannot get a very big sheet of paper all at once. What you get a small sheets of paper like this, right? So you get small sheets of paper like this, and which you will be using to decorate, like cover the entire part, right? So what we will be doing first, we'll be finding the TSA of the entire thing, which is she is going to cover. She's going to cover the wooden box, which is in the form of a cuboid, the upper part, the bottom part, the CS and TSA, which she's going to cover. So first we'll be finding out the TSA of that part, and then we'll be finding out the area of this single sheet, right? The area of this single sheet, and then we'll find the number of it, right? So what it is given to you, it's given over here. It's given that volume of, like, it's given like length is equals to what, 80 centimeter, breadth is equals to what, beta, 40 centimeter, and height is equals to what, beta, 20 centimeter. First she's going to cover it. So what we'll be finding out, that we are finding out TSA of what, cuboid, right? TSA of what, cuboid. So TSA is cuboid is of what, beta, 2 times of LB plus BH plus LH, right? So this is equals to what, 2 times of 80 into 40 plus 40 into 20 plus LH is what, 20, 80 into 20, right? So you just solve it. So it is 20 into what, 3200 plus 1600 plus it's 800. It's 800 plus 1600. So you just add it up. So 2 into what, beta, 400, 4000 plus it will be what, 5600. So this is equals to what, 2 into 5600. That is your TSA. Now then what you will be finding out, then you will be finding out the area of the what, square paper, right? So area of square paper will be how much, beta? Area of square paper is equals to how much, beta? So it will be what, 40 into 40, which is equals to what, 600 centimeters square, right? So the number of sheets required, will be equals to how much, beta? That is that is TSA of cuboid, right? TSA of cuboid divided by what, area of what, square paper. Yes or no, square paper, right? So which is equals to what, beta? 2 into what, 5600. See, I'm not multiplying, you can do like this also. 1600, this and this cancel, this is like 4 and this is like 1 and this is 4, right? So this is 1 and this is 2 and this is 1 and this is 7. So number of sheets required is what, beta? 7. Like number of sheets will be how much, beta? 7. That's it. Please write it down, beta, this thing. Now, let's do the question number 3. What it's saying, it says that a solid cylinder has a total surface area of 462 centimeters square. Its curved surface area is what, 1/3 of its total surface area. Find the radius and the height of the cylinder. So first, what it is given, just read it out the question. It says that the total TSA is given of the cylinder. TSA of a cylinder is how much, beta? 462, right? Now, what it says that the curved surface area is 1/3 of the TSA. So CSA is what, beta? 1/3 of TSA, right? Now, can I say that CSA will be equals to what? 1 by 3 into what? 462, which is equals to what? CSA is equals to what? 154? Yes or no? 154 centimeters square, right or not? Now, we have to find the radius and the height. Now, you have to think a little bit like this. So, CSA is how much, beta? 2 pi RH, which is equals to what? 154. Now, can I write this TSA is equals to what, beta? CSA plus the top and the bottom, that is 2 times of pi r square is equals to what? 462. Now, just substitute this. This is what? CSA value, which is like 154 plus 2 pi r square is equals to what? 462, right or not? Yes. So this is equals to what? 2 pi r square is equals to what? 12 minus 4 is what, beta? 8. And it's 0 and it's 3, right? So pi r square is equals to how much, beta? 154, right? So this is equals to what? 22 by 7 into r square, which is equals to like 154. So this and this is equals to 7. So r square is equals to what, beta? 7 square. So r is equals to how much, beta? 7. Now you can just find the value of the height. Height you can use either in the CSA or in the TSA, wherever you want to. You just put it over there and you get the answer, right? So CSA is equals to how much, beta? CSA we have like 154. You can put this value in the TSA as well. Your choice is yours, but I'll go with the CSA because this is like very easy to go, right? Which is equals to like 154, which is equals to what? 2 pi RH is equals to like 154 So 2 into 22 by 7 into h is equals to like 154. So 7 and 7 cancel, and this is what 7. So h is equals to what, beta? 7 by 2, or h is equals to what? 3.5 centimeter. This is your answer. Please write it down, beta, this thing.